Here's problem 23.6. If A is equal to 3 millimeters, B is 4 millimeters, Q1 is 60 nanocoulombs, Q2 is minus 80 nanocoulombs, and little q is 36 nanocoulombs in the figure, what's the magnitude of the total electric force on little q? So here's Q1, here's Q2, here's little q. And Q1 is positive, Q2 is negative, and little q is positive. So if we're to look at this, at least from our first perspective, we would see that between the two positive charges there will be a repulsive force in either direction, and in particular on little q there's going to be a force that's called F1 going to the right like this. And then between the positive little q and the negative Q2 there's going to be an attractive force, and that will go also to the right. Let's call it F2. So these two forces are going to add together, and they're going to be in the positive x direction. Let's find the magnitude of these two forces and then add them together. Alright, so force 1 is going to be equal to K Q1 little q, or the distance between them squared. That's going to be 9 times 10 to the 9 times Q1, which is 60 nanocoulombs, times Q2, which is 36 nanocoulombs, over the distance between them, which is the distance A, which is 3 millimeters. And we're going to square that. Alright, 10 to the 9 and 1 to the 10 to the minus 9s cancel out. And so far this looks like 9 times 6 times 36. 10 to the minus 9 times 10 will be 10 to the minus 8. All this over 9 times 10 to the minus 6. And 9's cancel out. 6 times 36 is 180, 216 times 10 to the minus 2. So this is 2.16 newtons. And it's to the right like that. Alright, let's calculate F2. F2 is equal to K little q, Q2, over the distance between them squared according to Coulomb's law. That's going to be 9 times 10 to the 9 times little q, 36 nanocoulombs, times Q2, which is 80 nanocoulombs, and we'll leave out the minus sign because we've already accounted for the direction of this force. So we just want the magnitude. And the difference between them is 4 millimeters. And we'll square that. Alright, so 1 to the 10 to the 9 and 10 to the minus 9s cancel out. This is a 36. So this is equal to 9 times 36 times 80, which would be 8, times 10 to the minus 8 over 4 times 4 times 10 to the minus 2. Let's see, 8 and the 4 gives me a 2 there, and then divide this will give me an 18. So 9 times 18, this is actually 10 to the minus 6 here. So we have 9 times 18, just do this on the calculator, 10 to the minus 2. So that would be 162 times 10 to the minus 2, or 1.62 newtons. And it's also to the right. So these two forces add together, F1 plus F2, and that's equal to 2.16 plus 1.62, which would be 3.78 newtons to the right. So we deal with the negative and the positive in terms of like charges repel, unlike charges attract. Find the directions that way. Just find the magnitude of these forces and then either add or subtract them according to their vector directions. In this case, they add 3.78 newtons to the right.